Okay. So your first exam will be on Thursday, October 8th. And I have already assigned the practice problem on MyLab Statistics. And I have also emailed you the information for exam 1. So if you have any question, you can ask me. So your exam will be 1 hour and 30 minutes, and there will be a total of 20 questions. So you'll have 12 multiple choice questions and 8 short responses. Yeah, but the exam will be open for 24 hours. So that's mean it will open on Thursday 12 a.m. and close at 11:59 p.m. So you can take the exam during any time during that period. But once you start the exam, you have to complete it within 1 hour and 30 minutes. Yes, you can take this practice. And I didn't mention it in the email. Yeah, but I think I should put that information on MyLab Statistics. So if you complete the practice problems before the due date, so I'll give you 5 points extra credit, and which will be added to your exam grade. Yes, sure. You can ask a question about practice problem. Yeah. So today's class and next class will be review class. So we'll go over, we'll try to go over all the practice problems during the class time. Yeah, but if you have any specific question about practice problems, yeah, sure, you can ask. Okay, so if you, what will be the extra credit? Okay. So I have already assigned the practice problems on MyLab Statistics. So if you complete the practice problems before the due date, so I'll give you 5 points extra credit, and which will be added to your exam grade. You're welcome. And I'll also put that information on MyLab Statistics. Any other question? So there are total 49 practice problems. So we'll try to go over all the practice problems during the class time. Okay. So if you do not have any questions, so we'll start going over the review problems. Any question? Okay, the first problem is the data from a sample of citizens of a certain country yielded the following estimates of average TV viewing time. So we have the TV viewing times per month for all the citizens. So we have the TV viewing times for all the citizens. Fill the chart and find the GS score, and it gave something like Z. Oh, yeah. Yeah, I understand what's your question. Yeah, we'll go over that problem. Yeah. Hopefully in the next class, we'll go over that problem. Yeah. Okay, thank you. Yeah, actually that's mean the 0.05 means the area is 0.05 and the area is on the right side of the distribution, or right side of the curve. You have to find the ZS score, corresponding ZS score for that area. Yeah, that's the question actually. We'll go over that problem. Yeah. Okay, the times are in hours and minutes. So here we have watching TV in the home. So this is about all the citizens, but they have this information based on the sample. So that's mean they are making inference. So is the study descriptive or inferential? Since they are making inference based on the sample, they are talking about the all citizens, that's mean population, that's mean they are making inference. So this is obviously inferential statistics. Now we have two options for inferential, A and B. And because the statistics are used to describe the sample, no, if the statistics are used to describe the sample, then that is called descriptive statistics. So it should be, the correct answer should be B. We can also check whether we found the correct answer or not. Okay, here we can check the answer. Yes, that's the correct answer is B. Okay, determine whether the study depicts an observational study or an experimental. A poll is conducted by a school's math department in which second grade students are asked if they prefer to be in their math class or their science class. So is the correct descriptive description of the study. So is it experimental study or observational? What do you think? Is it experimental or observational study? Yeah, this is observational, right? Yeah. So the answer should be the study is an observational study because the study examines individual in a sample but doesn't try to influence the response variable, right? The observation doesn't influence the response variable. So this is observational study. So this is the correct answer. Okay, the next one is determine whether the study depicts an observational study or an experiment. A poll is conducted by a school's, oh, this is the same question, I think. Yeah. I'm sorry, this is repetition. Yeah, you got the correct answer. This is observational study. Thank you. So a class has 50 students. Use the first row. I have seen that in the quiz, many of you did mistakes finding the random number. Some of you started from different row, and I think some of you didn't understand how to find the random number from the table. So we have to find the random number, and this is the random number table. So if the students are numbered 0, 1 to 50, so that's mean the numbers are 0, 1, 0, 2, 0, 3, and up to 50, 50. So what are the numbers of the 3 students selected? So we'll select 3 students. That means we have to find 3 numbers between 0, 1 to 50. And we'll start from the first row. So use the first row. So in the quiz, some of you missed this information. It was said use the third row, but some of you use the second row and some of you use the first row. So I graded this question manually. So even though you selected the wrong row, but I gave you some partial credit. Oh, question 3 is different. Okay, let me check. So poll is conducted by school's math department in which 50th grade students are asked if they prefer to be in their math or their English class.
Oh, I'm sorry. I'm following along on my exam too, and it's a different question.
Oh, okay. Mm-hmm. Yeah, I think, yeah, this is the same question. Okay, thank you. Yeah, so we have to start from the first row. So class has 50 students. Use the first row of this, so we have to use the first row. So and the numbers should be from 0 to 0, 1 to 50, right? So let's consider the first 2 numbers. So it is 72. It's not between 0, 1 and 50. Then 35, yes, the first number is 35. Then we have 93. No, we will not take this number. Then 27, yeah, that's correct, 27. Then 60, we are not going to take that number. Then 69, no. Then 37, yeah. So we have 3 different numbers. That's mean the numbers will be then 35, 27, and 37. Yeah, 35, 27, and 37. Yeah, so that's the correct answer. So this problem is a government agency monitors and reports on earthquakes. Providing daily real-time worldwide earthquake lists. Some of the information for particular earthquakes is shown in the following table. So we have the information in the table. So we have magnitude is given on the Richter scale, and NSD, this stands for the number of stations that reported the activity, and complete part A through part E. So we have actually, basically we have a table, and we are given some variables. We have time variable, we have magnitude, we have depth, we have NST, and we have region. Okay, so identify the type of data provided by the information in the first column of the table. So in the first column of the table, we have data and which is time. So this is 5 hours, 35 minutes, and so 5, 35, and 46. So first one is hour, then minute, and then second. So we have to identify the data type. So what do you think? Is the first variable quantitative or qualitative?
Quantitative.
Qualitative?
Quantitative.
Okay, quantitative, yeah. Okay, quantitative, and it says we have two options for quantitatives. Quantitatives continuous. Yeah, many of you are saying quantitative continuous. Okay, let's try this. Okay, so identify the type of, so how about the second one? Magnitude?
Would it be the same?
Yeah, it's obviously, yeah, that's correct. Yeah, thank you. So how about per C? Depth, it's same, right? Quantitative continuous. And NSD is, this is the number of stations, right? So that's mean this is quantitative but discrete. Yes, that's correct. And the last one is obviously this is qualitative, right? Okay, so let me check. Yes, we got the correct answer. Yeah, that's correct. Thank you. The next problem is explain the difference between each pair of concepts. So we have frequency and relative frequency. So basically that we have to find out which one is the correct definition of frequency and relative frequency. So the first one is frequency is the total number of observations in a data set. No, this is not correct, right? Frequency is not the total number of observations in the data set. Frequency is the total number of observations. No, B is not correct. C is frequency is the number of times a particular distinct value occurs. Yeah, that's the frequency. Number of times, how many times a value occurs. So that's the frequency of that value or that class. And relative frequency is the ratio of the frequency of the value to the total number of observations. Yeah, that's correct. Relative frequency is frequency divided by the total number of observations. So I think this is the correct answer. And part B, select the correct choice below. A relative frequency is the ratio of two percentages. No, this is not the ratio of two percentages. Relative frequency is the ratio of frequency and divided by total frequency. So this is not correct. Part B is relative frequency expressed as a decimal is the same as percentage. Okay. And how about per C? A relative frequency is the same as percentage expressed as a decimal. There is no difference between a relative frequency and percentage. So what do you think? Which one is correct? A, B, C, or D?
Are B and C saying the same thing?
B or yeah, it seems they're saying same thing, but not exactly. The first B is saying a relative frequency expressed as a decimal is the same as percentage. So that's mean it's basically saying the relative frequency expressed as like this. For example, 0.37 when the percentage is 37. And C is saying a relative frequency is expressed as percentage. Oh, sorry. same as the percentage. Oh, okay. A relative frequency expressed as a decimal is the same as percentage. A relative frequency is the same as percentage expressed. Oh, it is saying the same thing.
So then would it be there is no difference?
Yeah, I do not see any difference. Yeah, that's interesting. I thought that it is saying other way, but I think it's saying the same thing. Okay, some of you are saying correct answer is C, and some of you are saying correct answer is D. Okay, so let's try C, and yeah, C is the correct answer. But I think B and C are saying the same thing, right? And there is no difference between a relative frequency and a percent. Yeah, you can say that. Yeah, there is no difference between relative frequency and percentage because they're actually the same thing. Yeah, this question is a little confusing. Yeah, actually, personally, I didn't like this question. Yeah, this question is a little confusing because I think B, C, D, yeah, they're the same thing. Yeah, to me. Let me clear the annotation. So a simple qualitative data has been provided, dataset has been provided, complete parts A through D for this dataset. So we have to complete part A through D. So we have a dataset A, B, C, D, E, and D, D, C, A, D. So determine the frequency distribution. First, we need to determine the frequency distribution. So this is a qualitative data. So we have different categories. We have A, B, C, and D, and E. We have 5 categories. So first we need to list all the categories. Then frequency corresponding to is category. So for A, the frequency is 2, right? So how many A's we have here? We have 2 A's. And we have how many B's? 1, right? How many C's we have? 2. So how many D? 1, 2, 3, 4. And we have just single A. So the frequency is 2, 1, 2, 4, 1. So the total is 10, right? The total is 10. So now we have to find the relative frequency. So the relative frequency is 2 divided by total frequency. So 2 divided by 10. So that's mean this is 0.2. It will be 0.1. And this one will be 0.2. And this one is 0.4. And this one is 0.1. Yeah. So that's the relative frequency. So draw a pie chart. Choose the correct answer, correct chart below. So we have to draw a pie chart. So for A, this is actually 0.2 is 20%, right? So that's mean A is 20%. So first one is not correct because it's saying A is 10%, but we have A is 20%. And this one also saying A is 10%. So this is not correct. So D is also not correct. A is 10%. So surely C is correct. Even you do not check all the numbers, right? All the categories. Here from the by checking the first one, we found the correct answer. So this is part C. Now construct a bar chart. Choose the correct answer below. And similarly, we have to look at the height of category A, B, C, D, E. So A will be 0.2. Yeah, I think it looks correct. But B should be 0.1. But here they are same, right? So this is not correct. So how about this one? Yeah, it seems this is 0.2 and B is 0.1. Okay, let me check the other chart before checking the other categories. So B is higher than A here in per C. So this is not correct. This is also not correct. So that's mean the answer should be part B. Yes, part B. Yeah, you got the correct answer. Thank you. Okay. Yeah, so we got all correct answer. That's great. So question number 8. So it is similar type of question. So we have different number of categories, different. So champion, college A, college D, college C. So we have 4 categories here, A, B, C, D. And we have also the frequency, right? Corresponding frequency. So we have to just find the frequency, how many times they became champion, right? So how many times college A became champion? So that's mean how many times college A occurred? So 1, 2, 3. So do you want me to go over this one, or should I leave this one? It's a similar type of question. Maybe we have, yeah, maybe we can go over one more. Yeah, we can go over one more example. Okay, let's go over this one. So first we need to find the frequency. So how many times college A occurred? 1, 2, 3, 4, 5, 6, 6 times. So that's mean the first one will be 6. Okay. How many times B occurred? 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. And how many times C occurred? 1, 2, 3, 4, 5, 6, 7. 7 times. And how many times D occurred? 1, 2, 3, 4. So total 25. Total number of observation is 25. And we have all the frequencies. And we have the total frequency. Okay, now we have to calculate the relative frequency. That's mean frequency divided by the total frequency. So 6 divided by 25. So that will be 0.24. So the first one is 0.24. Then second one is 8 divided by 25. So that's mean 0.32. And third one will be 7 divided by 25. So 0.28. 0.28. And this one will be 4 divided by 25, 0.16. And you can also check whether your answer is correct or not, because if you add them together, then it will be 1. So draw a pie chart. So the first one is 24%. So this is 20%. This is 20%. So in C, we have 24%. That's correct. And in A, we have 24%. That's correct. So now we need to check for B. So B is 32. Yeah, this is 32. But in part C, we have B is 28. So that means C is not correct. So the correct answer is then A. And similarly, we have to find the correct bar chart. So first one is A is 24. So this is, I think, 24. That's correct. B is not correct. And how about this one? This is, it seems also maybe 24. Yeah, let's keep these two for now, A and C. And we can eliminate D because A is not 24% in D. So that's when we can eliminate B and D. So now we have A and C, and check for college B. B is 32. It seems 32. But this one, it seems higher than 32. Okay, so let's check D. D is 28. Yeah, it seems this is 28. Okay, so B is 32, right? Yeah, I think this is higher than 32. So I think the answer should be this one. Okay, so let's check the answer. Yeah, we got the correct answer. Okay, so I'm not going to go over this one. This is similar type of questions, so you should go over it by yourself. Okay, so this is also similar type of problem, but we have here continuous and continuous variable. So we have numbers instead of categories, but it's similar type of question. So that's when we have to, for frequency, we have to find how many times we have zero. We have 0, 1, 2, 3, 4, 5, 6 times. And so it will be 6. How many times we have 1, 2, 3, 4. So this one will be 4. How many times we have 2, 1, 2, 3, 4. So this is also 4. How many times we have 3, 1, 2, 3. We have 3 times. And how many times we have 4, 1, 2, 3. So total number of observation is 20. So relative frequency will be then 6 over 20, which is 0.3, 4 over 20, which is 0.2. So this one will be then 0.3, 0.2. This one will be also 0.2. This one will be 0.15. And this one will be 0.15. 3 divided by 20 and 3 divided by 20. Okay, now we have to find the histogram. Since this is quantitative data, so that's why this is called histogram, not bar chart. For qualitative data, we say bar chart, but for histogram, we say, sorry, for quantitative data, we say histogram. And here the bars are adjacent. Okay, so this is 0.2, 0.2. Oh, this is the histogram for the frequency, not the relative frequency. Okay, so that's mean 60. The first one, sorry, for the frequency for the first one is 6, but for 0 we have lower than 5, so this is not correct. However, this one, yeah, this is 6, but for 1 and 2 it should be 4, 4, but we do not have 4 and 4. However, this is not also correct, because the first one should be 6, but we have 4. Yeah, first one is 6, then this is 4, this is 4, then this is 3, this is 3. Yeah, that one is correct. Then construct a relative frequency histogram. So we have to find the relative frequency histogram. So you have the similar type of histogram, but only difference is this is frequency and the vertical axis is frequency. And for this one, the vertical axis will be relative frequency. So find the chart which is similar to this one. So this is not correct, because this is not similar to this one. This is not correct. This is also not correct. Yeah, the first one is similar to this one, right? So that's mean this is the correct answer. Yeah. So we got all correct answer. Do you have any question? Am I going too fast, or the pace is okay? Okay, thank you. Thank you. Yeah, I want to go over this one because this is continuous random variable and we have decimal points. So we have to use grouping, right? Yeah, for continuous variable, we have to use grouping. Yeah. So a simple quantitative data set has been provided. Use cut point grouping. And I think there should have some questions where you will be asked what type of grouping you need to use for a particular set of data. Okay, determine our frequency distribution. the first class, that's mean this class is 45 to under 50. So it is given, this information is given. The first one is from 44 to 50. So now we have to complete these classes. So for cut point grouping, the first group is 45 to 44 to under 50. So this one will start from 50, right? And the difference between 45 and 50 is 6. So 50 minus 45 is 6. So this number will be then 56, because the class width will be same for each class in this case. So then this will be 56 and plus 6, that means 62. And this one will be 62 plus 6, so that's mean 68. And this one is 68 plus 6, that's mean 74. And you can see that all the numbers are between 44 and 74. We do not have any numbers which are outside below 44 and above 74. Okay, now we have to find the frequency. So how many numbers we have between 40 and under 50? So for this one, you can use actually Telemark, and that will help you if you use Telemark. Okay, let's consider the first number, which is 53.5. So first number will be in this group, 53.5. So we have one number. Second number is 54.1. So this will be also in this group. Then 57.1. 57 is in this group. Then 51.1. 51.1 will be also in this group. Then 68.6. So 68.6 for sure it will be in this group. 51.2. Yeah, this is in this group. Then 46.7 in the first one. Then 65.6. This is in this one. Then 63.9. 63.9 it will be here. Then 51.6. 51.6 should be 51.2. Yeah. So we have 5 numbers here. 73.9. 73.9 is here. Then 59.8. 59.8 is here. 56.9 is here. 62.1 should be here. Then 48.4 should be here. Then 55.2 should be 55.2 should be in this group. Then 62.2 should be in this group. Then 58.8 58.8 should be in this group. 52.1 should be in this group. Okay, now if we have a number which is, for example, 56, then in which group this number should go? What do you think? In the second one or third one? Because we have in the second one we have 56, and in third one we have also 56. Yeah, here this is obvious, right? The second group is 50 to under 56, so that's mean 56 is not there. And third group is 56 to under 62, so that's mean 56 is in the third class, right? Yeah. Oh, did I skip 62.3? Okay. Okay, let me check how many numbers we have. 2, 6, 10, then 6, 16, 18. 1, 2, 3, 4, 5, 6. Oh, we have total 20 numbers. Yeah, I think I skipped 2 numbers maybe. 62.3 is, yeah, thank you for letting me know. 62.3 should be here. So now we have 6, 8, and I think I skipped one more number. I don't know which number I skipped. Okay, so 53.5. Yeah, that's how we will. Okay, let me check. 53.5 is here. This. So how many numbers we have from 50 to 45 to 50? 45 to 44 to 50. We have 1. We have 2. Yeah, the first one we have 2. In the second one, we have 1, 2, 3, 4, 5, 5, 6. Yeah, okay. So we have also 52, 7. I think we have 7 numbers here. Yeah. Yeah, that's great idea. Yeah. If you open the table in the Excel sheet and if you sort them, then you will easily get all the numbers, right? Yeah. Yeah, that's good idea. Yeah. Thank you. Yeah, you can do that. You can open the numbers in Excel sheet. You have to just click on this, click to copy the table and open it in Excel. Yeah, you can do that. Yeah, that will help you actually. Yeah, I can show you like how you will do that. So you will open this one. Okay, I need to share this one. Yeah, thank you. Yeah, you can open it in Excel sheet. Yeah, now to sort it, you need to select it, select them, then right click and sort. So you can do smallest to largest or largest to smallest. So here do smallest to largest. Yeah, then it will sort. And now you can easily find how many numbers from 50 to, sorry, 44 to 50. So we have just 2 numbers. Then 50 to 56. Even if you select them, you can see the count here. So we have 7 numbers. Yeah. Then 56 to 62. We have, you can see the count here. We have 4 numbers. Then 62 to 68. We have 5 numbers. Then we have 2 numbers in the last group. Yeah, that's how you can easily find. Yeah, thank you. That's how you can easily find the frequency. Oh, I lost everything. Anyway, that's fine. I have it. So we have total, we have 2, 5. I think we have, the first one is 2. Then we have 7. Then we have, can anyone tell me what's the frequency of this group? I think this group we have 5, and in this group we have 2. So what is the frequency of third group? Do you remember? Or maybe I can check. Yeah, we have 4 actually. Yeah, in that group we have 4. Yeah, we have 4 numbers here. I think that's correct. Now we have to find the relative frequency. So we have total 20 numbers here. So you will divide each one by 20. Yeah, first you need to complete this group. So it will be the same group actually. 40 to under 50, then 50 to 56. Then you have 56 to 62. So you have to write exactly the same numbers. Then you will find the frequency, relative frequency. So here actually this will be 50, this one will be 50, and then 56, and this is the corresponding frequency. So 2 divided by 20, that's been 0.1, and 7 divided by 20 is 0.35, and so on. Yeah, so I'll leave it like this, and please complete it by yourself. Okay, do you have any question? Okay, so this question is about stem and leaf plot. So we have to find the stem and leaf. So we have 2-digit numbers. So here we have 40, 47, and 60, 40, 41, 38. So choose the correct stem and leaf diagram. So first you have to look at the first digit. So how many distinct digits we have? So we have 4, we have 6, 5, 2, 3. So 2, 3, 4, 5, 6. So we have 2, 3, 4, 5, 6. And then for 2, the first number is 4, 47. So 4 is the stem and 7 is leaf. So that's mean you have 7. And then the second number, this number is 44. So the stem is 4, then the leaf will be also 4. So that's mean basically you will do this. So first you will write the stem. So we have 2, 3, 4, 5, and 6. We have 2, 3, 4, 5, 6. So first number is 47. So we'll have 7 here, then 44, then we have 4 here. Then this number is 60, 60. So we'll have 0 here, then 5, 8. We have 8 here. So then 4, 0. So we'll have 0 here, then 29, that's mean 9 here, then 41, we'll have 1 here, then 53, so we have 3 here, then 38, we'll have 8 here, and then 33, we'll have 3 here. Now you need to rearrange the leaf in order. So this is the leaves. So we have to rearrange them in ascending order or descending order. That's when in increasing or decreasing. So then it will be 2, 3, 4, 5, 6. So we have just 9, and this one will be 3, 8. This one will be 0, 1, 4, 7, and this one will be 3, 8, and 0. So this is not correct. 380147 38. Yeah, it seems this is the correct answer. Yeah, let's check this one. This is not correct. Yeah, this is not correct. So the correct answer is B. Yes, the correct answer is B. Great. Yeah, the correct answer will be B. Yeah, thank you. Okay, so this is a random sample of 45 households. Yielded the data given in the table on the number of working computers. Use single value grouping to complete pairs A and A through D. So how many distinct observation we have? So to find the distinct observation, you can also open this one in Excel. So right click on this icon, then open in Excel. Yeah, then it will be opened in Excel sheet. And if you work on the Excel sheet, that will be easier. So let me share the Excel. Yeah, this one. Yeah. Here you can also sort this one, select this one. Then you need to select the numbers from here to here. Then sort and smallest to largest. So what are the distinct number? We have 0, we have 1, 2, 3, 4, 5. So we have 0, 1, 2, 3, 4, 5. So let's go back to the original problem. Yeah, okay, sorry. So we have 0, 1, 2, 3, 4, 5, 6. It's already there. So now we have to find the frequency. So from the Excel sheet, you can easily find the frequency. or you can also count here, count from here. So how many zeros we have? We have 3 zeros here, 3, 4, and 7. So 8, 9. So we have 9 zeros. So you have to just write 9 here. And similarly, you have to count all the ones, and you have to write the 1 here. And then this is actually a similar question. I don't know why did I assign so many questions to this type, similar to this type. Yeah. Okay, explain the meaning of the term distribution of a variable. So what is the meaning of a distribution? So you have to choose the correct answer from below. The distribution of a variable is another name for the population distribution. So whenever we say distribution of a variable, that means the distribution of the population, not the sample or not the mean. Yeah. So the distribution of variable is another name of sample distribution. This is not correct. The distribution of variable is another name of mean of population. This is not correct. The distribution is a variable of a variable is a distribution of all possible values for a variable. The distribution of a variable is another name for the population distribution. Okay, so the distribution, yeah. So let me check this one. Yeah, it seems this is it. So whenever it's said that the distribution of a variable, so that's mean the distribution of a population. So it should be answered part A. The correct answer should be part A. So here we are given a smooth curve that represents a distribution, and the distribution is provided. Use this curve to do the following. So first you need to identify the shape of the distribution with regard to modality. So that's mean whether the distribution is unimodal, bimodal, or multimodal. So here we have just one mode, right? We have just one peak. So that's mean this is unimodal distribution. Yeah, that's correct. This is unimodal distribution. Yeah, thank you. And the distribution is, so this is the skewness or the shape of the distribution, whether it is symmetric or skew distribution. So we have to determine, yeah, this is symmetric distribution. That's correct. And the distribution is, yeah, that is the same question. So it should be also symmetric. Yeah. Yeah, this is correct answer. So you got the correct answer. Thank you. Yeah, here the distribution is, this is also unimodal because we have just one mode here, one peak, and the distribution is skewed. So that's mean non-symmetric. And this is the skewness, it has left tail. So that's mean this is, okay, so you say part B, yeah, this is left skewed distribution, that's correct. Yes, we got the correct answer because we have left tail, long tail at the left of the distribution. Okay, the cholesterol levels of a sample of children between the ages of 4 and 19 years of age were measured in this unit. I'm not exactly sure about this unit. This is milligram per, I don't know. Yeah. The relative frequency histogram for the data is shown to the right. So this is the relative frequency histogram, and state whether the distribution is roughly symmetric, right is skewed, or left is skewed. So which of the following best describe the given distribution? So what do you think? This is nearly symmetric, right is skewed, or left is skewed? Okay, this is right is skewed. Okay. Yeah, so let me check whether this is right is skewed. Okay, so what you can do, you can add the midpoint of each bar and draw the curve. Then the curve will be the curve will be like this. Yeah, it seems okay. So let me check whether this is right is cute. Yeah, this is right is cute. Yeah, you got the correct answer. That's great. So identify the modality and symmetries, symmetry of the distribution of the data set. First, use the technology to find the distribution for the data set. Choose the correct answer below. So first you need to find the distribution of the data set. So here you have the data set. So you can open them in Excel sheet, and then you have to find the distribution of the data set. Okay, so once you get the distribution of the data set, then you have to find the identify the both modality and symmetry of the distribution. Yeah. Okay, so first you need to, yeah, this question is for this question, actually you need to use the spreadsheet. Otherwise, it will be really tough to answer these questions, because first you need to draw the plot for the data. So first you need to open them in Excel sheet, and then you can plot them. You can plot the data, and then after plotting the data, so that's mean you have to know how to construct histogram in a spreadsheet. Yeah, for this question, you have to know how to construct histogram in a spreadsheet. Okay, so try this one by yourself. If you cannot find this one, so ask me in the next class. So I will show you how to construct histogram on a spreadsheet. Yeah. Once you know how to construct the histogram on a spreadsheet, it will not take much time, because constructing the histogram on a spreadsheet is very easy. So you have to just select the data, and then you have to, there is icon called data. Yeah, I will show you in the next class if you cannot find it. Okay. The next question is, use the data set below to complete parts A through C. So we have 5 numbers here, 6, 4, 7, 9, 14. So we have to determine the mean, determine the median, and determine the mode. So the mean is, you have to add them together and divide by 5. So if you add them together, then it will be 6 plus 4 plus 7 plus 9 plus 14. So this is 40 divided by 5. So that's mean the mean will be 8. The mean is 8. Then you have to rearrange them in increasing order to find the mode. So to find the mode, you have to rearrange them in increasing order. So 4, 6, 7, 9, and 14. So in the quiz, I have seen that some of you didn't rearrange the data. Just you consider the middle value as the mode. So if you do not rearrange, then the mode will be 7. And luckily, even if you rearrange them, the mode is 7. So even if you do mistake, you will get the correct answer here. Yeah, 7 is the median. I'm sorry, 7 is the median. Yeah, so the 7 will be median here, right? Even if you forget to rearrange the data, you will get the correct answer, because in here the 7 is in the middle, but you will not be always lucky. So select the correct choice below, and if necessary, fill in the answer box to complete your choice. The mode is, or mode, how many modes we have? Yeah, you already got the answer, right? There is no mode. Mhm. Okay, so let me check. Yes, we got the correct answer. Okay, so let's move to the next one. So the next question is, the dataset below shows the additional sleep in hours obtained by a sample of 10 patients given a certain medication. Complete parts A through C. So the dataset below shows the additional sleep in hours obtained by a sample of 10 patients given a certain medication. Okay, so is it observational study or this is experimental study? What do you think? Though this question is not here, but yeah, this is experimental, right? Because they were given a certain medication. So that's when they were given a treatment. So this is experimental study. So we have to find the number of observations. So we have 10 observations. So n is 10. So that means this number will be then 10. Then we have to find the sigma of xi. So if you do not know this notation, this is very easy, but if you do not this notation, then you will not be able to find it. Sigma of xi means summation of x1 plus x2 up to, we have 10 observations. So that's mean x10. So x1 is 1.1, the first one, plus 0.3, plus 0.6, and so on. So that's when we have to, basically we have to add them together. So if you add them together, then 1.1 plus 0.3 plus 0.6 minus 0.1 plus 0.4 plus 3.6, then plus 4.1 plus 1.3 plus 4.7 plus 3.5. So that's mean this is 19.5. So the summation of xi is 19.5. Then the sample mean will be divided by 10, so 1.95. So hopefully we get the correct answer. Yeah. So that should be the answer for these questions. Okay, so in 2000, for a certain region, 47.8% of incoming college freshmen characterized their political views as liberal, 26.8% as moderate, and 25.4% as conservative. For the current year, a random sample of 500 incoming college freshmen yielded the frequency distribution of our political views shown below. So this is the political view of freshmen. So we have three political views: liberal, moderate, conservative. So we have three categories. So first we need to determine the mode of the data using the given frequency distribution. So from this frequency distribution, you have to find the mode of this data. So choose the correct answer. So which one should be the correct answer? Or you can also choose multiple options. So what do you think? Which one is the correct answer? And would it be appropriate to use either the mean or the median as a measure of center? So what should we use in this case as a measure of center? Should we use mean or median? So what do you think? So which one should be the correct answer for A, and which one should be the correct answer for B? And A can have actually multiple answer. Okay. Conservative mode. Okay. Now, actually you have to select from mean or median. Would it be appropriate to use either the mean or median as a measure of center? So we do not have any option to select mode. You have to select from either median or mean. Or if you think that mean and median are not appropriate, then maybe none of them. Yeah. So which one should be the correct answer for A and B? Okay. So the mode is, some of you said conservative, and some of you said the mode is conservative. Okay. Yeah, I got many answers for conservative. So why do you think that the mode is conservative? So look at the frequency. The category which has highest frequency will be the mode, right? So which one has highest frequency? The mode means the category where the number occurred most, right? So that's mean, yeah, it should be liberal. The mode is liberal, yeah. Okay, so how about part B? Should I use mode or mean as a measure of center, or none of them? Okay, so you have to be careful about the type of the data. So this is qualitative. So for qualitative data, we cannot calculate the mean, we cannot calculate the median, right? So only we can find the mode. Yeah, the mode is the center, but here you have to find either from mean or mode. So that's mean neither the mean nor the median can be used, right? We cannot use mean, or we cannot use median as a measures of center, since the data set is qualitative. So the answer should be the first one. Do you have any question? Okay. So consider the data set in the accompanying table, complete parts A through C. So look at the table first. So we have this data set. Can you see the data set?
Yes.
Okay, that's great. So we have this data set. So we have to find the sample standard deviation. So we need to find the sample standard deviation. Then replace the 16 in the data set by 166. Then we have 16 at the end. So you have to replace it by 166. And again, use the defining formula to compute the sample standard deviation. Then find the sample standard deviation again. And compare your answer in part A and part B. The lack of what property of the standard deviation accounts for its extreme sensitivity to change of 16 to 166. Okay, so when you will be changing 16 by 166, you will see that the standard deviation will change a lot. So you have to interpret what's the reason behind this. So first you need to calculate the standard deviation for this one. So how can we find the standard deviation? So in exam, I will recommend you to use a spreadsheet to calculate the standard deviation, because it will save your time. Yeah, unless you are asked to show your work. But you should also know how to calculate the standard deviation by hand. So you should also know that. So if you are not asked to show the work, then I'll recommend you to use a spreadsheet to find the standard deviation, or you can also use calculator, the graphing calculator. That will also work. Okay, so to find the standard deviation, so open the data in Excel. Okay, so let me, yeah, I opened it in Excel sheet. So can you see the Excel?
No, sir.
Yeah, you can see the Excel sheet? Or
No, sir.
Oh, no. Okay. So, okay, let me share it. Yeah. Okay. I hope you can see now, right? Mhm. Okay. So to find the standard deviation, so if you select them, then here you can see only the average, count, and at the bottom you can see only the average, the count, and sum. So that's mean you have to find it. So how can I find it? So select this column. So yeah, select this one, then equal, and for standard deviation you need to write STD, standard deviation. So this is the standard deviation, or you can select also this one, the standard deviation. Now we have to select this number, and then in the parentheses, so the standard deviation is 2.74. Okay, now replace 16 with 166. Then calculate the standard. Oh, I'm sorry. Yeah, first it was 16. Okay, so I can just copy the data set again. So I can copy the data set here, and now I will replace 16 with 166. So now find the standard deviation, equal STD. So this is the STDEV, standard deviation, and now you need to select all the numbers, and this is 51.55. Now you can see that like how the standard deviation changed. So it's extremely sensitive to outliers. So this is 2.74 and this is 51.55. 2.74 and 51.55. So this one is 2.74 and 51.55, right? So compare your answer in part A and part B. The standard deviation in part B is greater than the standard deviation in part A, right? Yeah, that's correct. The standard deviation is not resistant to outliers or is not the appropriate measure if the data set changes. The preferred measure of variation, the appropriate measure for a small is not the preferred measure of variation, is not the appropriate measure of a small data sets. So which one should be the correct?
Resistant to outliers.
Yeah, because it's extremely sensitive to outliers, right? Yeah, so we got the correct answer. Yeah, thank you. So we didn't select the other options because the appropriate measure if the data set changes. Yeah, you cannot say that. If we change 16 by 15, the data set has been changed, right? But the standard deviation will not change that much. So that's mean this is not correct. The preferred measures is not the preferred. Yes, this is the preferred measures for variation. Yeah, we already discussed it, right? When we discussed the standard deviation. The appropriate measure for a small is not the appropriate measure. Yeah, this is also not correct. Yeah, this is even we can, for a small data set, we can use the standard deviation. Yeah, so that's mean this one should be the right choice. Yeah. Okay, do you have any question? We have total 49 problems, so we are on question number 23. So we need to at least finish 2-3 more problems. Yeah. Okay. So each of the following smooth curves represents the shape of a data set. In each case, decide whether application of the empirical rule to the data set is appropriate. Explain your answer. Okay, so if you click on this icon, you will see these three plots or these three graphs. Okay, this is the graph for part A, this is for part B, this is for part C. Now the question for part A is decide whether application of the empirical rule is appropriate for curve A. So what do you think? Can we use empirical rule in this case, or do we have to use Chebyshev's rule? So can we use empirical rule in this case? Okay, we said C, the empirical rule is appropriate. Yeah, empirical rule is appropriate in this case because this is symmetric, right? But the reason is the data is a quantitative data, that's correct, and the distribution is roughly bell-shaped. Yeah, this distribution is roughly bell-shaped. So that's why we can use empirical rule. Yeah, you're right. The answer should be part C. Option C, sorry. So for part B, this is right skewed distribution. So the empirical rule is not appropriate in this case. So that's mean we can eliminate the last two options, C and D. This is not appropriate. So look at the first one. The empirical rule is inappropriate because the data set is quantitative. So the curve cannot represent the data faithfully. No, this is not correct. The empirical rule is inappropriate because the data is quantitative, but the distribution is asymmetric, right? Not symmetric. So this is the correct answer. So how about part C? This is also left skewed, not symmetric. So that's mean the empirical rule is inappropriate because the data is quantitative. This is not qualitative. The data is quantitative. So for sure, this is the answer. Therefore, Chebyshev's rule provides the better estimates. Okay, the idea is when you have skewed data, then you will use Chebyshev's rule for finding the person. Do you have any question? Any question? Okay, thank you. Yeah. So then number 24, a quantitative data set of size 80 has mean 45 and standard deviation of 5. So we have mean for sample size n is 80, mean x bar is 45. So this is a sample data and standard deviation S is 5. So at least how many observations? So we have to find at least how many observations lie between 25 and 65. So between 25 and 65. So the first thing you have to find how many observations, how many standard deviation away from the mean is this one, and how many standard deviation away below from the mean is 25. So if you subtract 25 or 65 from 45 from 65, then it will be 20 and divide by the standard deviation. So that's mean this is 4 standard deviation away from the mean. And similarly, if you subtract 25 from 45, then you will have 20 and divide by 4, it will be also 4. So that's mean 25 is 4 standard deviation below from the mean, and 65 is 4 standard deviation above from the mean. So now that's mean we have to find this is the mean. We have to find the number of observations between 4 standard deviations from the mean. So that's mean x bar, this is x bar plus 4 times standard deviation, and this is x bar minus 4 times the standard deviation. Or if you consider the population data, then this one will be mu and this one will be sigma. Okay, whatever it is. So here this is 4 standard deviation away. So that's mean K is equal 4. So the number of observations will be then 1 minus 1 over K square times 100%. Okay. So that's mean 1 minus 1 over 4 square times 100%. So that's mean 1 minus 1 over 16. So if you calculate this one, 1 minus 1 over 16, then it will be 0.9375. So that's mean 93.75% observations will be between 25 and 65. So now you will multiply this number with n. So n times 0.9375, so that's mean 80. So we have 75. So we found 75. So whatever number you will get, you will consider plus 1. So it will be then 76. If you get, you will round up. So if you get, for example, if you get 72.1, you will consider 73. If you get 50.6, you will consider 51. So we have 75. So that's mean at least 76 observations will be between 25 and 65. Yeah. Do you have any question? Okay, thank you. Thank you. So we have 2 more minutes. I think we can go over one more example, one more problems. So consider the sample of exam scores to the right, arranged in increasing order. They are arranged in increasing order. The sample mean and sample standard deviation of this exam score are respectively, sample mean is 83.1, sample standard deviation is 17.1. So that's mean the X bar is 83.1 and S is 17.1. Chebyshev's rule states that for any data set and any real number K greater than 1, at least this percent of observations lie within K standard deviation. Yeah, that's what we used in the previous example. So use Chebyshev's rules to obtain a lower bound on the percentage of observations that lie within 3 standard deviations to the either side of the mean. So use the Chebyshev's rule to obtain the lower bound on the percentage. That's mean you have to find at least what percent of observations will be between 3 standard deviations from the either side of the mean. And part B, use the data to obtain the exact percentage of the observations that lie within the 3 standard deviations to either side of the mean. Okay, so here you have to use the Chebyshev's rule to find the lower bound. That's mean you have to find the at least what percentage of observations will be within 3 standard deviations. Okay, to do that for part A, here K is 3, right? 3 standard deviations. So that's mean 1 minus 1 over K square, this person. So that's mean 100 times 1 minus 1 over 3 square. So that's mean 1 minus 1 over 9. So it will be then 88.87. So this is 88.87%. So this is the minimum. So at least 88.87% observations. Sorry, this is the lower bound of the percentage. Yeah. So use the data to obtain the exact percent of the observations that lie within the 3 standard deviations of either side of the mean. Okay, so for part B, you know the mean value, right? X bar is 83.1 and you know S is 17.1. Okay. Okay, so I'll finish in 1 minute. So if you have any class or If you need to leave, then yeah, you're free to leave. But I'll just take 1 more minute, okay? Okay, for part B, we know X bar is 83.1 and S is 17.1. Okay, so now you have to find X bar minus 3 times 17.1. And here we have actually X bar 83.1. And 83.1 plus 3 times 17.1. So calculate this number and this number. So the first number is 83.1 minus 3 times 17.1. So which is 31.8. And second number is 83.1 plus 17.1 times 3. So this is 134.4. Okay, so now you have these two bounds. 30, this is the lower bound and this is the upper bound. So now we have to find how many numbers are between these two numbers. So how many numbers are between 31 point? So I think here total we have how many observations we have? Okay, so anyway, you have to count the numbers which are between these two numbers, then calculate the percentage. That will be the answer for part B. Okay, so I'll stop here and